Good afternoon, everyone. Welcome to our AIA Aero Insights webinar on strengthening America's supply chain. I'm Katie Summerlin Barron. I'm AIA Senior Director of Policy Communications. And our two panelists today are Steve Jordan Tomaszewski. He is Vice President of Space Systems at AIA, and Doug Anderson, Partner at PwC Operations and Supply Chain. We will be taking questions during today's webinar, so feel free to drop them in the chat. This webinar is being recorded and will be sent around after this event. And both AIA and PwC, we'd love to sit down and discuss our insights more with you. So please feel free to get in touch anytime after this. So with that, we will dig in. Can you guys talk a little bit about why now and briefly share what prompted PwC and AIA to look at this issue? We'll start with Steve.
Sure, Katie, and thanks for pulling this all together. So we're very excited for everyone to join us here today to learn about what some of the challenges are to build satellites and launch vehicles in the space supply chain, and also to provide some recommendations of how do we grow the space industrial base. So this effort really started a while back. As you know, AIA has traditionally been an organization that has represented manufacturers across the aerospace and defense industry. We've been doing that for over 100 years, and we thought it'd be a good time right now to really unpack the space-specific supply chain issues. So what is stopping us from scaling up manufacturing of satellites, launch vehicles, and rockets? And where are some of the kind of common pain points kind of across the industry? So I think if we want to go to the next slide, this is just talking a little bit about what we were looking at and the reasoning behind this. And we'll get into that here in a second, but let me maybe turn it over quickly to Doug to explain a little bit about how PwC is engaged on supply chain issues.
Thanks, Steve. Thanks, Katie. Exciting to be here with you guys today. Yeah, I mean, really, the impetus for this study was just because a lot of our clients that we've been working with have been coming to us and asking for help with their supply chains related to, like Steve said, launch vehicles, satellite manufacturing. And so, we just thought, wow, with all these companies really encountering these same challenges, why don't we dig in deeper in this, do some targeted interviews, data collection, and see what we find and see if we can, distill that into some recommendations. And so that's what this study was all about.
Something that I've just heard a lot from not only industry executives, but also from folks across government recently is, what's stopping the space industrial base from growing? What are those common challenges that everyone's kind of facing? And so I hope that we're going to have a lot of different folks that are joining us here today for the webinar. But from a government perspective, some of the takeaways that you should be getting from this are, why is it difficult to build satellites and launch vehicles, and what are some of the current challenges that we have? If you're dialing in from industry and you want to know, where some of those potential bottlenecks are going to be as you're scaling up operations, or maybe where there might be some investment opportunities for increasing manufacturing and building new satellite factories. I think this is going to have some great insights here. And then we really are excited that the way that we are looking at the results here, we'll kind of get through some of that today, is focused on concrete recommendations of what things could make this better. So I think we'll be getting into that of, from the government side, from the industry side, and where there needs to be partnership to make sure that we're really growing the industrial base.
Next slide. Let's get into demand drivers. So we're seeing 4 different demand drivers all at once. What makes today's space demand cycle fundamentally different from previous demand growth cycles we've seen?
Yeah, I mean, I think everyone here probably knows that, the US space sector is just entering a period of rapid expansion, and it's not just the national security priorities, the government missions anymore. It's all the commercial space and civil exploration programs. And so, these big mega constellations in satellite internet, and then potentially the coming AI data centers in space. These are big drivers, and exploration and the government programs, the national security reconnaissance programs, those haven't slowed down either. So it's really just by really any metric that you look at, whether it's launch cadence, whether it's objects in space or active functioning satellites, kind of generally they're all up about 10x in 10 years. And the pace just continues to increase. Even just the space economy is now becoming a meaningful part of the US economy, like something like 0.5% of GDP and 370,000 private sector jobs. So these demand forces are really coming together to just drive unprecedented growth and demand.
This is a really exciting time to be in the space industry, as we do see a lot of new applications for space systems, and growing demand across the board. But I think what this is trying to show is just a lot of the demand, in the individual sectors of space, of civil or national security or the commercial sectors. It is a lot to drive a lot of change. But adding this all together, and especially the potential for whole new areas and whole new mission areas, is really what's transforming things right now. Space traditionally hasn't been an industry that was ready for mass production. We look back and we see, bespoke, exquisite satellite systems that are made at small scales, that do some amazing work. But right now, we are really kind of seeing that tipping point, and new opportunities, for launch, new opportunity for satellite production, and making sure that paired with a lot of the new manufacturing technologies coming online these days, we want to make sure space doesn't get left behind as an industry, and want to make sure that the space industry overall is able to grow to keep up with all the different demands.
So we're seeing this huge surge in demand, and why hasn't that translated into meaningful increase in capacity?
Yeah, great question. And just, on that surge in demand, right? We see it at the top level, some of the stats I just mentioned that we talked about on the last slide. And then as you look into some of these metrics here, on the left side of this slide, we talked about the increase in launch cadence activity. But translating that down, we've seen a 30% increase in aerospace manufacturing output. But we're getting that not just from new investment and expansion of facilities. A lot of these manufacturing facilities that support the space supply chain, the average age of those is like 26 years old. So how have companies met and been able to increase output by 30%? Well, they've stretched their capacity. They've worked their assets harder. So certainly there's been some new investment, but a lot of the increase in output to meet that demand has been from the current supply base, just simply, sweating in their assets harder. And so, and really, I guess, why is that? Why have they not gone and made those new investments? And there's a number of reasons, and we talk about some of them on the right side of the page here. There's competition with other industries. There's a lot of global disruptions. Certainly, there's a lot of legacy regulations, and just not enough investment. So, yeah, we're really seeing a large increase in output to meet that demand, but a lot of it's just coming from increasing utilization of existing assets.
And I'll just add on, if we think that growth in the space industry is rapid and it's changing day by day, which it definitely is, that under that point of competition with other industries, look at the artificial intelligence industry or kind of how data centers are coming online. This is where space is kind of competing against. We're about to see some examples of that where, literally it's hard for space manufacturers to get their hands on things because they're getting gobbled up by other industries out there. So, as excited as we all are about space, and we see some of these trends, going in very interesting directions, it's also part of the bigger aerospace and defense ecosystem, and then just part of overall manufacturing worldwide.
So let's take it down to the component level. Next slide, please. What stands out to you as the most fragile or the least resilient part of the space supply chain?
So this is the part of the results that I'm most excited about. So just to recap of what everyone's seeing on the screen here, we went out to talk to some of the leading space manufacturers across the industry, and we asked them, what are you having difficulty getting your hands on? What might have long lead times? Where are prices really high? And in some cases, you just might not ever be able to get your hands on quality components that are ready to go for a spacecraft. But the other thing about this is just recognizing the fact of like why space is hard and why manufacturing satellites is difficult. It's because to put something up into the space environment, which is a very harsh environment, you're dealing with having to survive going up on a launch vehicle, which is extremely loud and it has a lot of vibration. You're going into the vacuum of space. You're having a lot of times big temperature swings. You have a lot of radiation effects. So that harshness of the space environment is why these things are so difficult to operate in space. And space has a lot of very specialized components. So what you're seeing on the screen right here is like the top 9 components that are difficult for industry at large to get your hands on, to make launch vehicles and to make satellites. So I think Doug is going to kind of walk through the reasons why and some of the highlights here. But if you want to know what some of the top challenges are of why it's hard to scale up manufacturing, this is the slide to kind of take a look at.
Yeah, and Steve, you did a good job talking about some of the requirements that make space difficult. One thing I would add on to that is just the reliability needs to be super high because if you're putting up multi-billion-dollar spacecraft, you can't have a valve or a connector or one of these things, fail on you. So they need to be very high reliability, very high quality. And so, we talk about, I mean, and like Steve said, these are what we heard from the companies and folks that we interviewed as these are the things that they're struggling with the most. They're struggling with it from the standpoint of high cost, very long lead times, and just a limited number of suppliers that even are interested in making these components. A lot of these can have lengthy and complex supply chains. So it's not like one supplier just makes the whole thing, right? Look at, let's say, the pressure vessels, the carbon overwrap pressure vessels or other propulsion tanks. These might have exquisite carbon fibers that kind of go through a long supply chain. They might be a forged titanium that again is a long supply chain. You look at like the rocket motor nozzles, these carbon nozzles that are again a very long, lengthy supply chain, very complex, and can get down to a single provider, a single company that's making a rayon fiber that's needed in that. And then sometimes lots of capital investment, large ovens or other heat treating type equipment that's needed to produce these. And there's actually like 8 components on here that we heard a lot about. And then the bottom right corner talks about post-processing. So we heard from a lot of folks that it's not even just the components that are hard to get, but some of the processing, some of the testing that needs to be done to these. That again can funnel down to a small number of suppliers that can do that testing, that can do the post-processing type activities. And again, it lengthens out those lead times, makes them difficult to get. Another aspect of this is that, you know, these components, look here at like the connectors or the field programmable gate arrays, the FPGAs, or valves or actuators, right? They're used in other industries as well, and often in much higher quantities. And so, you know, when a company is looking at meeting the demands of a space customer or serving a commercial customer that may have a lot less requirements, testing requirements, you know, paperwork requirements, they might choose to serve the commercial demands. I talked just about a lot of extensive testing and qualification. That's certainly the case with all these for the reasons that Steve talked about to meet those requirements and ensure that high reliability so we don't lose a spacecraft or it doesn't function once it gets up there. So these are some of the core challenges faced that we heard about for these 8 or 9 different components where it's really critical, difficult supply chain challenges.
And what I might just add on here is that you see a couple of different categories of things, right? So there's things that are definitely needed to manufacture satellites, things like optical intersatellite links, the connectors to kind of pass data and electricity around a satellite. You see parts of launch vehicles here, like the composite overwrap pressure vessels and the rocket motor nozzles. And then you also see things like switch gears and transformers, which I think was a really interesting part of this study. So those types of electrical equipment, like switch gears and transformers, are needed to provide electricity to things on the ground. So think about if it's a manufacturing facility, maybe it's a launch pad, maybe it's a telemetry tracking and control station for a satellite. But it's really difficult for industry, the space industry, to get their hands on those electrical components right now. And it's because they're competing with data centers, with a lot of the non-space parts of the industry. So we see those effects where space is told to go to the back of the line sometimes with extremely long lead times for certain types of these items. And so if you're looking to stand up a new factory, you might not even be able to in the near term because you're going to be dependent on some of this equipment to just make your factory function.
Speaking of cost, what drives space components to be so much more expensive than their commercial counterparts?
Yeah. Well, Steve talked about a lot of these requirements, you know, the temperature requirements, the vibration, shock, radiation requirements, all the requirements that enable these components to function in the harsh environment in space and do it reliably. It means that these space grade components can be, as you see here, 7,000% more costly than the commercial component. And in addition to just cost, the lead times, the ability to procure these materials, the time it takes to get your hands on them, can be measured in literally years. And so, um, we like I said, the space grade connectors here, the example that we have here is 76 times more than a standard commercial connector. That FPGA there, the space grade one might be 100 times more expensive than the commercial equivalent. And it's not just the ability to meet these requirements, but it's the testing that goes along with it. It's the qualification. It's having the paperwork that says, yeah, this component really is going to stand up to the space environment.
I'll just add, Katie, I went to Ace Hardware this morning and bought myself a connector off the shelf, $5.59 for this thing, right? But they didn't have a space grade section at Ace Hardware, so I wasn't able to get the latest price change this morning. But to Doug's point, there are really good reasons why making space grade parts, costs a lot more. And it's because of all the challenges of operating the space environment. So, what I think we're now starting to talk about is how do we fix this? How do we grow the space industrial base? How do we alleviate some of these supply chain bottlenecks? And this testing piece, I think, is really important. And this is something that we heard from a number of companies of if there were ways to make sure you can test parts before they go to space first, do that faster, increase the volume of testing. That is one of the current bottlenecks. So, having more testing facilities out there, I think is going to be a way that you can actually find ways to drive down the price overall, but really to increase the volume at the end of the day.
So when strong demand exists, suppliers still hesitate to invest. Why is volatility in space such a powerful deterrent to capacity expansion?
Yeah, I think that's a great point. So, Doug and I we were talking about before of all the demand and all the new interest in space. However, it's important to note that that demand can really fluctuate year over year. So we would direct folks to the full report to kind of see some of the unpacking some of those numbers, especially from a federal government demand signal and why it can be so volatile over time. But I think folks in this webinar can point to challenges from the federal government where we have things like government shutdowns, continuing resolutions, and just kind of breaks in appropriations of how some of that demand can kind of trickle down very sporadically. So if you're a company looking to make new investments in the space supply chain, or maybe to increase satellite manufacturing, you want to make sure that that demand is going to be there once you get your factory going. You're not going to be able to build a satellite factory overnight. So these things just take a lot of time. So the more that demand can be stabilized and consistent, that provides the right signals, to the private sector to make sure they're making those investments in new manufacturing facilities.
Yeah, and just to add some stats there, that chart, on the upper left, that says illustrative, but that's actually real. We measured year over year changes in program level funding, and those swings were really dramatic from, a 56% increase one year to a 49% decline the next. And so, to what Steve was just saying, like if you're a supplier and you're looking at a demand signal that's moving up and down like that volatile, you're going to be, and maybe you're a small supplier, you're going to be very cautious with the capital that you're going to invest. And that goes back to the point that we made at the beginning of the webinar, which is what we've seen in these companies is that they've just been stretching their utilization of their assets. Well, this is part of the reason why. It's not a stable demand signal. It's not something that companies have been able to, use to underwrite their capital investments to really expand their manufacturing capacity.
I'll jump in here real quick and just remind everybody to put any questions in the chat. Sorry, Steve, go ahead.
Oh, no, I was just going to add, if we're looking at the right side of this chart here, this is one of the recommendations coming out of this report, is find better ways to share information about challenges faster, and especially between government and industry. So something that we uncovered talking to companies was that there can be a big delay sometimes between, hey, we have this challenge or this bottleneck or a delay of getting a certain component, and being able to address that in a rapid fashion is just not there these days. So, I think from a government perspective, if you're trying to ask questions like, why are my, satellites that we have on contract, behind schedule? How do we kind of fix this? The first thing that you have to do is really find ways to identify the problems quickly, so then you can take more rapid action. So this sort of a platform of just finding a way to share information about early and often about some of these challenges is a really good first step to try to understand and then address some of these issues.
Yeah, and another thing that we found in this study is the government, when they're, putting out a procurement for a program, haven't necessarily evaluated the supply chain to see will the supply chain be able to meet the demand for what I'm asking for the number of satellites or for the different components. They haven't really looked at the capacity and the ability for the supply chain to meet the demand. And so if there's if it takes every part, to make a launch vehicle or a satellite, and all the suppliers need to invest to be able to meet that demand, it starts to become, a bit of a game of, well, if I make the investment and somebody else doesn't, and the whole program slows down, I'm going to be left with the stranded capacity. So, that was another thing that we found, that we really think that this type of information sharing platform and government doing a better job of understanding what's the ability of the supply chain to meet the demands that we're asking will help to alleviate and address some of these challenges.
Great. I see we've got one question in the chat. I think we can go ahead and go to our last slide, and then we'll get to questions. Okay. Regulation is clearly necessary in this industry, but where does it start to unintentionally constrain the supply chain?
Yeah, so one of the things that we found is the regulatory complexity and the certification requirements that especially small businesses have to deal with to enter the and participate in the space market. There's a lot of, you know, compounding regulations and costs associated with meeting those regulations and being compliant. That come together, that whether it's cybersecurity, CMMC, or manufacturing like AS9100, or meeting ITAR, or other regulations. It's difficult for small suppliers to pay for, to afford to meet those requirements. And if they have options to participate in the commercial side of the business, they might choose to do so. And so, one of the things we talk about here is, are there targeted incentives or targeted financing that could encourage new suppliers to enter critical segments of the supply chain where competition is limited, and could government maybe help with financing, or with just helping companies navigate, and make it easier for them to be compliant.
On that one, Doug, before you kind of move on to the next section, I would just kind of add, for a lot of companies, when all of the new regulations and requirements kind of pile up, it's almost like a death by a thousand cuts, right? So for manufacturers that want to expand to do more space work, to build launch vehicles and satellites, the barrier to entry is just so high, and it can be very prohibitive across the board. So as Doug was kind of walking through, of like, finding better ways to allow companies to be in compliance, finding ways maybe to jumpstart and make sure they can get the right certifications that they need, perhaps some opportunities for government to change the requirements. I think that's another big piece here, right? Of looking for opportunities to kind of dust off something that might not have been looked at for a while, making sure that it's meeting all of the modern day needs. And I think that's across the board what we kind of saw talking with companies in the space industry. Sometimes they're even kind of self-regulating of being stuck in a lot of legacy requirements that maybe aren't even applicable anymore. So how do we modernize those requirements, those regulations, and then also kind of help more companies get into the supply chain?
Great, thanks, Steve. I think that's it for our content. Do we have one more
Katie,
slide?
I want to cover maybe a couple more points just back on
Oh,
that
yeah,
last slide.
please go back.
Um, the second one there on the right-hand side, the risk management as a constraint. So what we mean there is what we heard is that a lot of the prime contractors might be taking a conservative approach to interpretation of, regulations and other compliance requirements, and then flowing those down to their suppliers. And that maybe say overly conservative approach to risk management is driving cost, it's driving complexity, and it's driving, frankly, suppliers out of that supply chain. And so, one example is like CMMC, where that's the cybersecurity regulation that especially says if you're going to handle, ITAR or other, confidential CUI type data, you've got to be compliant with this cybersecurity regulation. Very important. But if a you know, prime contractor flows down that CMMC regulation to all of its suppliers, even the ones that don't really need it, that might be driving unnecessary cost into the supply chain just simply because of a more conservative review of those regulations. So that's another one where we say take a more risk-informed oversight and provide clearer regulatory guidance that helps companies better apply a risk framework, a risk assessment to flowing down those requirements. And then the last one here on this slide, just the labor and logistics challenges. Our study really focused on components and the hardware. But we did hear from a number of folks about labor and logistics challenges and primarily around the ability to attract labor to their suppliers and the manufacturing operations because there's a lot of you know, requirements, again, compliance requirements. There's security, export control, access to facilities. So there's a lot of requirements to bring employees on board at many of these sites. And those requirements, again, make it more difficult to attract labor. And so, one recommendation here is perhaps we could create a more standardized type of clearinghouse, if you will, where employees can be sort of certified to be able to then not have every single supplier that wants to hire somebody have to go through those same processes. They can kind of be done in a maybe more centralized fashion. So that was one of the other recommendations. So those are kind of the main findings from the study. And yeah, with that, Katie, I'll turn it back over to you.
Yeah, is there anything you guys would like to add before we get into questions? We're ready to dive in.
Just something that kind of Doug kind of pulled the thread on. I think for anyone that's been talking about space supply chain over the last several years, the focus has really been on kind of security of the supply chain, making sure that you have integrity of the components, that your cybersecurity is shored up, making sure that our potential adversaries haven't infiltrated your supply chain somehow, and all of that is going to continue to be very important for space, especially since we have so many critical technologies that are really enabling our modern way of life. However, one of the big points that I think we're raising in this study is it's time to scale up. We need to strengthen the supply chain overall and find ways to do things at scale that'll make manufacturing a lot easier. So with that, that trusted supplier certification recommendation that Doug just outlined, are ideas like that it's probably time for us, maybe long overdue, in the space manufacturing world, to find ways that we can really do a lot of this work at scale, and buy down a lot of that risk overall.
Awesome. Thanks, Steve. Steve and Doug's contact information is on this slide if anybody wants to reach out or talk offline about the results of the study. And with that, we will get into our first question. So the first question, I'm just going in order of how they were put in the chat. Are there parallels with the supply chain challenges experienced in the space-specific industry that overlap with the commercial defense aerospace industry that can be maximized for economies of scale? Or can these industry challenges be tackled somewhat jointly?
Yeah, I think, one thing that comes to mind here is like the fasteners that are used in both commercial aerospace as well as in launch vehicles. There's simply a small number of manufacturers that produce these type of aerospace grade fasteners. Um, you might know there was a fire at one of these uh, suppliers not too long ago, and it caused a big disruption. And so, again, to Steve's point, like we need more investment in these types of suppliers. We need to build more capacity, and part of that is we need to see kind of that demand signal, out into the future, a sustained demand signal that helps to spur investment to build more of these suppliers, to introduce new competition, and capacity.
And I might just add to that um, looking at space compared to kind of overall kind of defense or commercial supply chain challenges and opportunities, um, space needs to have a seat at the table when we're talking about increasing the industrial base and growing manufacturing. There is a lot of energy right now focused on growing the defense industrial base, as an example, making sure that we have enough, munitions and other types of, defense applications to meet our national security needs. Well, we need to probably do a better job on the space side of the house to articulate what the problems are, and then how these alleviating some of these problems can contribute to some of our overall, national objectives, whether that's space exploration, science, kind of national security applications, and so, you know, I think one of the examples would be, we need to have more connectivity for people overall to be able to talk where you might not be have access to a cell phone tower, or when you're trying to do missions all around the world. Optical intersatellite links, even though it's a technical term talking about laser communications terminals on satellites and kind of lasers talking to the ground, those are a new technology that are really unlocking a lot more communications to be able to send via space. So it's trying to pull that thread and tell that story. I think that's what we could really need to focus on this year. I think 2026 is really going to be the year of the space supply chain. There's a lot of government and commercial interest of looking at what the problems are and how do we kind of make things better, which is great. And I think this study really is getting at to some of those specifics. What's that next level down? Okay, we can't scale up production because these are kind of some of the bottlenecks right now. And then, how do we start getting into the implementation phase of some of these recommendations?
The year of the space supply chain. I'll move to our next question. What is the effect of competition or lack of competition among manufacturers for specific components on the cost of those components?
So certainly, I don't know if this was a softball, but certainly when there's lack of competition, we see it all the time. So I totally get the question. Like the cost is just increased dramatically. I think the other part of this, though, is, it's also about the lead times. The lead times just get extended out so long that it becomes, difficult for companies. And it's not just the manufacturing lead times. It might be, the development, qualification, the testing lead times. It's all those things that add up together that say, hey, you might place an order today and the cost is going to be far above what you were hoping it was going to be, or you might have budgeted for. Um, and you're going to have to wait, 50, 80, 100 weeks to get this component. So certainly that lack of competition drives up cost and certainly drives extended lead times.
I think this is why I'm excited about this report, is that I think we could have stopped of like, hey, where are the problems right now? Where are those bottlenecks? Give me that, top 9 list of components, and stop there. But the immediate follow-up question I think everyone would ask is, how do we fix this? Thanks, Tom, for the question. I think the way that you get more competition in the industry, which is good for driving down prices, good for increasing volumes, and getting at increasing the supply overall. It's a number of specific things, and it can get pretty wonky pretty quick, of figuring out exactly what policy, maybe legacy regulation or requirement, what things can Congress do, what things should some of the major satellite manufacturers just kind of do on their own, how do we fix testing facilities, and how do we unlock new entrants to enter the space industry better, right? So the full report, which folks should see that the link in the chat here as well, kind of outlines a number of things that you can do. But make no mistake, there is no silver bullet to immediately fix the space supply chain overnight. It is a number of consistent lines of effort that a lot of times require government and industry to work together on. And not just, but there are some things industry can do on their own, certain things that government can do to have better visibility and to kind of work and help make strategic investments at time or modify policies and regulations. So it's not going to be a fully comprehensive list of all the things that we can do, but hopefully this will be a good roll up for folks just to understand where those pain points are, but then also how we can fix it working together.
We've had some great questions so far. I'll move to our next one. What can commercial space companies do to overcome friction points around regulatory and compliance requirements if they want to participate in DoW programs like Golden Dome for America, for example?
Yeah, another good question. And we talked about a little bit about taking a risk-based approach to evaluating those and flowing down those regulatory and compliance requirements. Another thing that we help our clients with is challenging some of those requirements. Some of the specifications for these components and requirements are from legacy programs that date back many, many years, and that maybe haven't been challenged and maybe driving a lot of cost into the supply chain, maybe driving some of those lack of competition and the lengthy lead times. And so challenging some of those requirements. Certainly, we want companies to be in compliance when it comes to the regulatory ones, but on some of the more specifications and things that have flowed down from older programs, we want to challenge those and make sure that they're valid for our particular mission. Take, for example, a radiation requirement that may be very different if you're going to a higher orbit compared to a low Earth orbit. And if you're, building everything to meet that higher radiation requirement, you may be introducing a lot of extra cost and limiting your supply base.
And I might just answer that of one of the best things that companies can do is be aware of all of the regulations that are impacting their manufacturing operations, and then advocate to change them, as appropriate. We heard from a number of companies that, hey, they found out that there is a particular government regulation that's been in place for a long time that's been inhibiting their ability to move around parts around the country for testing purposes. But it turns out that the government was looking to get some feedback to modify the regulation. So from a company perspective, being aware of what those regulations are is important, and then work at your company to kind of tell those stories of why this is inhibiting you from doubling the size of your factory as appropriate. Working with trade associations that can kind of collectively use the voices of companies across the industry to kind of describe these bigger problems, I think is a big part of it. And then look at making strategic investments. So I'm hoping that this list, especially of those top 9 components, can provide a little bit of direction to folks about where there could additional investment, how that would help the industry overall, right? So whether your company is looking to scale up vertical integration of a certain one of these components, whether you're looking to attract foreign direct investment to increase your facilities, whether you're trying to partner with the government, looking at a certain type of contract award to increase space manufacturing, those opportunities, this is a great place to start. Also just give the caveat that these things do change over time. So it's going to be interesting to see, this year of some of the top issues that surfaced, is that going to be the same as next year, or are some of these going to be bottlenecks be alleviated? And then getting back to that idea about the bidirectional data sharing platform, the faster that industry and government can identify problems and potentially find some fixes, the better it's going to be for the industry overall. Whether your company is looking to support very bold new initiatives like the Golden Dome for America initiative and all the elements of that, including new applications for space like the space-based interceptor layer, the things we've kind of pointed out in this study are going to be the bottlenecks that you will most likely run into if you wanted to start scaling up satellite manufacturing. So being aware of that and making some investments early, and then kind of working between government and industry, providing feedback on the regulations, I think is a great place to start.
We have time for one more question. We're coming up on time, about the recommendations of this study. How do you expect civil and national security space agencies to respond to these recommendations?
I can start, Doug. I really hope that for a number of these recommendations, it's probably there's a lot of things that I'm sure civil and national security space agencies have heard before, because some of these have been persistent problems for years, and some of these are not unique to space. But what I hope this study can point out is that these continue to be challenges and deserve a fresh look to be see if they can be addressed. I think overall, the federal government is very receptive to hearing from the space industry right now of what they can do to help grow the industrial base, and potentially modify regulations and policies to make it easier to scale up manufacturing. So it's going to be up to everyone to see how we can advocate to change things. One of the things I'm hoping that we're going to do as kind of part of the follow-on for the release of this report is really have opportunities to kind of sit down with government leaders, whether that's at civil or national security space agencies, some of the regulators or folks in Congress, and try to figure out what the best path forward for solving some of these issues are. Because I think for some of these recommendations that we're bringing up, there's already kind kind of things that might already be in place to be a good start. And then others might have just been, this might be kind of a first heard thing here. So, it's going to depend on what recommendation that we're talking about. But, from a AIA perspective, we're really excited to work, with government and help them connect to industry better to see how we can make some advancements and to grow the space industrial base.
And I'll probably just add one, small point here, Steve, is I think that, the government, the civil and national security space agencies, I think they're gonna find these insights, well, these findings very insightful. I think especially when it gets down to the component level of like where are the real challenges at a component level within the supply chain. Because they may not be hearing that from their prime contractors who are really just trying to meet what they've been asked for. So I think this will be eye-opening for them, and I think they'll be interesting to engage and jointly solve these problems together with them.
And Doug, I'll just add quickly, there was in 2023, the Department of Commerce kicked off a civil space industrial base study and surveyed a whole bunch of companies to figure out what some of the big challenges were. But that study was never released. Right. So I think that's even something that we thought about into unpacking this issue is, how can we, be helpful and provide some of those insights when there's not a comprehensive government effort to really work on this right now. So this is, not going to be an end all be all of identifying every issue under the sun. We tried to just focus on some of the most impactful things that we heard kind of across the board. But it's definitely looking forward to working with government folks and from companies just across the industry to see how we can make some of these recommendations and actually implement them.
Well, Steve, Doug, as we wrap up, are there any other closing comments you guys would like to make?
I'll just say, echo what you said, Katie, at the beginning, that if any of you are interested in engaging further and discussing the findings in the paper, we're happy to do that.
And no, I just want to thank everybody here for dialing in. We're very excited about this effort. It's been a long time coming and a lot of hard work behind the scenes. We're looking forward to following up with folks about this. And it's really going to be an interesting year as we're getting into the implementation of some of these recommendations. And we welcome any ideas or ways to kind of make this better. So thanks for everyone's attention on this.
Great. Well, thank you to our panelists and thanks everyone who joined. The link to the study is in the chat and the recording of this will be available on AIA's YouTube page.